Hi dear students, welcome to Geeta's classes. So in this class we are going to solve a COSM question paper which was conducted on 11th September 2021. So let us see one by one. This time the question paper was very easy and almost everyone would have done very well. Okay, so state and prove first question, first part is state and prove Bayes theorem, and so many times we have discussed this Bayes theorem. Therefore, I am giving the proof directly. If you want detailed description, then you can go to the channel and watch. So second one, companies B1 and B2, B3 produce 30%, 45%, 25%. So there are three companies. So first company produces 30% of the cars, so 0.3, and second company is producing 45%. Therefore, probability that the car is produced by B2 is 0.45, and for the third company it is 0.25. Right. Next is what is given. It is known that 2%, 3% and 2% of these cars produced from these companies are defective. That is, if you are producing the car is produced by the first company B1 and the car is defective, the probability that it is from B1 is 0.02. That is, all the 30% cars are produced by B1. In that 30%, how many cars are defective? What is the probability that the cars are defective by produced by B1? That is why first we are selecting the company and what is the probability that it is defective. Okay, so 0.02. Similarly, D given B2 is 0.03 and D given B3 is 0.02 and so on. This is the given data. Okay, what is asked, if a car purchased is found to be defective, what is the probability that this is purchased from the company B2? Okay, so we are going to use Bayes theorem. This is application of Bayes theorem only. So what is that? I am taking a defective car. I have purchased one car and it is defective. What is the probability that it has come from B2? So first we are selecting the defective car, and what is the probability that it has come from B2? That is why probability of B2 given D. And I asked you to remember like this, probability of just you interchange these two, D given B2. Okay, and into whatever is there in the denominator you have to write probability of B2. Similarly, in the here D given B2, not denominator, D given B2, after B2, after given what is there, B2. So that should be written, that should be multiplied. Similarly, it should be written for all the possible cars. Okay, all the possible companies B1, B2 and B3 in the denominator. So substituting these values, you will be getting 0.551, right? And next is required probability is probability that the car purchased is defective. So it may be from B1, it may be from B2, or it may be from third company B3. Okay, so what is there? P of B1 into P of D given B1, etc. What is there? It is there in the denominator. Already we have calculated it to be 0.0245. Okay, you have to substitute the values and write. Okay, this is for your reference. That's why I am not substituting the values. Already we have done in the denominator. That's why I am writing the values. For exam, you have to write all the, substitute all the values and write. Okay. Next is 2a, the probability distribution is given by. So, and this time I have told you either the discrete probability or continuous probability, one definite question. But this time they have asked both discrete and continuous. So 2a, the probability distribution is given by, and find the value of k, 2 less than x less than 5, and probability of x greater than or equal to 6. So what is the first one? Find the value of k. What are you going to use? This total probability sigma p of x is equal to 1. That is, total probability is 1. That concept only we are going to use. That is k plus 3k plus 5k plus 7k plus 9k plus etc. plus 17k is equal to 1. That is 81k is equal to 1, implies k is equal to 1 by 81. 1 by 81. Okay, and you can, if you want, you can substitute. It is 1 by 81, 3 by 81, 5 by 81 and 7 by 81, 9 by 81. You can add one more column and you can write like this: 11 by 81, 13 by 81 and 15 by 81 and 17 by 81. You can add one more row if you want and you can write. Okay, then second one is probability that 2 less than, strictly less than x less than 5. P of 2 less than x less than 5. Strictly means you should not add this. So it is up to from 3 and less than 2 less than x less than 5. That means only 3 and 4. Okay. So probability of 3 and probability of 4 you have to write. So probability of 3, probability that x is equal to 3 plus probability that x is equal to 4. What is there? X is equal to 3 is 5k and 7k, right? 5k plus 7k, that is 12k. 12 into divided by 81. K is 1 by 81. So 12 by 81, that is 1.1481. Okay. Then what is the next one? Probability that x is greater than or equal to 6. Probability that x is greater than or equal to 6. Greater than or equal to 6 means what? P of 6 plus P of x is equal to 6 plus probability of x is equal to 7 plus 8, x is equal to 8 plus P of x is equal to 9. 6, 7, 8, 9, that is 11, 13, 15, 17. So 11k plus 13k plus 15k plus 17k. How much you will be getting? 40, 52, 56, right? 56k, which is 56 divided by 81. 81. So 0.6914 is the answer, right? So next is second one, continuous PDF, and here again in the place of y they have given, in the place of f of x they have given y. So y is equal to given, y is equal to k into 3x squared minus 1, where minus 1 less than or equal to x less than or equal to 2, 0 otherwise. This is the meaning. They have not mentioned, but it is the meaning. Okay. That means what? Only from minus 1 to 2. Only in this interval it is defined, and here it is 0 up to minus infinity. Here it goes up to plus infinity also. Here it is 0. Okay. So in this area, in this interval it is 0. In this interval also it is 0. Only from minus 1 to 2 it is defined. Therefore, first we have to find out the k. That is again we are going to use the total probability is 1. What is total probability? Minus infinity to plus infinity. Y dx is equal to 1. But here it is defined only from, that is minus infinity to plus infinity means you have to split it into minus infinity to minus 1 plus minus 1 to 2 plus 2 to infinity. And this term will get cancelled. This term will get cancelled. Only from minus 1 to 2 you will have. So integral minus 1 to 2. Y is what? K into 3x squared minus 1 into dx is equal to 1. Okay. That is k, I will take it outside. Minus 1 to 2. 3x squared minus 1 into dx is equal to 1. Right. That is k into 3 into x squared is, if you integrate you will be getting x cubed by 3. Minus, if you integrate x you will be getting x. So minus 1 to 2. 3 will get cancelled. It's equal to 1. That is k into, when you substitute the upper limit, it is 2 cube minus 2 for upper limit, and lower limit minus 1 the whole cube minus of minus 1 is equal to 1. What about this value? 8 minus 2, it is 6. Minus, what about this value? Minus 1, minus of minus plus 1. So this will become 0. Okay. So 6 minus 0 is equal to 1. Implies k is equal to 1 by 6. Okay. And what is asked? What is the next question? Probability that minus 1 less than or equal to x less than 0. So probability of minus 1 less than or equal to x less than or equal to 0 is equal to, less than or equal to 0 or less than 0 is also 1. Okay. Is equal to, in this interval you have to integrate. So minus 1 to 0, whatever is asked in that interval, y dx. Okay. And k is equal to, we know it is 1 by 6. So after this you can substitute. Therefore y becomes 1 by 6 into 3x squared minus 1 in the interval minus 1 less than or equal to x less than or equal to 2. Okay. 0 otherwise. So minus 1 to 0, 1 by 6. K is already 1 by 6 we have found out. Integral minus 1 to 0, 3x squared minus 1 dx, which is equal to 1 by 6 into 3x cube minus x from minus 1 to 0, which is equal to 1 by 6 into, when you substitute the upper limit, x and x will become 0, and lower limit also, it will be minus 1 the whole cube minus of minus 1. So this will become 0. Therefore everything will become 0. Here this is minus 1 plus 1. Therefore it is equal to 0. Therefore for upper limit also 0, lower limit also 0. Therefore the value is 0. And next one, the mean of a Poisson distribution is 2. Find p of x greater than 0, x less than 3. These two are asked. Now what is given? Mean of Poisson distribution means lambda. Okay. So given lambda is equal to 2. First you write the generalized expression. P of x is equal to x is e power minus lambda into lambda power x by x factorial. Lambda is 2, just substitute. So e power minus 2 into 2 power x divided by x factorial. So first part is p of x greater than 0. Greater than 0 means still what value we don't know. So 1 minus of p of x less than or equal to 0. Less than or equal to 0 means only one value, x is equal to 0, right? So 1 minus of, for x is equal to 0, in the place of p of x, small x, in the place of x you just substitute 0. So e power minus 2 into 2 power 0 by 0 factorial, so that is 1 minus e power minus 2, just substitute, you will be getting this value 0.8647, and strictly less than 3, p of x less than 3, strictly less than 3 means less than or equal to 2, so 0, 1, 2, just substitute these values. We know that p of x is equal to x, that's what we have substituted. X is equal to x is e power minus 2 into 2 power x by x factorial. In this, x is equal to 0, x equal to 1 and x is equal to 2. If you substitute, e power minus 2 is common, I can take it outside here. First term it is 1, second term 2 power 1 it is 2, and third term it is 2 power 2 by 2, that is 4 by 2 it is 2. So 5 into e power minus 2, this is the value 0.6765. Okay. And next is 3b, it is binomial distribution. And all are direct questions only this time. So P is 0.5, Q is also 0.5, because we know for binomial distribution it is P plus Q is equal to 1. Okay. We know that. Therefore Q is equal to 0.5. 1 minus 0.5, it is 0.5. And given n is equal to 7. So generalized expression is P of x equal to x is 7cx 0.5. P per x. This is P and this is Q. Okay. P per x into q per n minus x. N is equal to 7 here, that's why we have substituted. So x is equal to 2, 7c2 into 0.5 the whole square, 0.5 the whole power 7 minus 2. 7c2 is 7 into 6 by 1 into 2. So just cancel, and the value is 0.1641. Okay, just simplification. So this is actually 0.5 can be written as 1 by 2. That's why we have written 2 power 7 in the denominator. Okay. And next is 1 less than or equal to x less than 3. So actually here they have given probability of modulus of x less than or equal to something. I think it is a printing mistake. That's why I have considered it as 1 less than or equal to x less than 3. Sometimes it may be 0 less than or equal to also. I think if you have done like this, they will give full marks. So p of x less than x is equal to 1 plus p of x is equal to 2. Assuming that this is 1 I have written. Okay. So 7c1 for x is equal to 1, just substitute ncx. Here what is p of x is equal to x? 7cx 0.5 the whole power x and 0.5 the whole power n minus x. Okay. So x is equal to 1 and x is equal to 2, we are substituting here. So when you simplify, you will be getting, you can directly use the calculator for calculating this, or you can write 7 into 6 by 1 into 2 and 0.7 by per 7 also. Okay, 0.5 the whole per 7 also you can write. So next is normal distribution, 15 marks. It is the easiest question they have given. Suppose the weights of 800 students are normally distributed with mean 140 and standard deviation 10. So given that mu is equal to 140, sigma is equal to 10. So first one is between 138 and 148. So probability of 138 less than or equal to x less than or equal to 148. So x is equal, when x is equal, x values are given, because we are going to use the normal table, we have to convert x values to z values using the formula z is equal to x minus mu by sigma. Okay, so when x is equal to 138, it will become minus 0.2, and when x is equal to 148, it will become 0.8. Okay, so p of 138 less than or equal to x less than or equal to 148 means what? Probability of minus 0.2 less than or equal to z less than or equal to 0.8. Okay, so here this is the value. So minus, this is the probability we have to find out, and this is the area in the graph. Okay, but whenever you want to make use of the table, you are supposed to express in terms of 0 to z. This is the area given. Okay, so if you want to make use of this table, then we have to use this. We have to express the given area in terms of 0 to z. So I am splitting this into two, this area and this area, minus 2 to 0, 0 to 8. Because it is symmetric about the line z is equal to 0, minus 2 to 0 is equal to 0 to 2. So that's why I am writing like this, 0.2 to 0.8. And for 0.2, what is the value? 0.2, 0.20. So 20 means this is 0.0793. So 0.0793 plus 0.80. 0.80. 0.80 means 0.2881. 0.2881. Okay, 0.80. So 0.2881. This is the value, and when you add this, you will be getting 0.3674. But this is the probability is given, and you are supposed to find out that into 800 number of students, right? So you have to find the number of students between 138 whose weight, number of students whose weights are between 138 and 148. So, number of students whose weights are between 138 and 148. That is, this is the probability. You have to multiply by 800. So 293.92. That is approximately, because it is number of students, you cannot write in terms of integers, fraction. So it should be rounded off. So 293. Okay. And next is more than 152. So x greater than 152 means z is equal to x minus mu by sigma. And if you simplify, you will be getting 1.2. Greater than x greater than 152 is equivalent to z greater than 1.2. So greater than 1.2 means, and always remember, minus, negative means you have to write in the left hand side, positive means you have to write in the right hand side. So right hand side it is 1.2, and more than 1.2, therefore it is in the right hand side. And what about this area? Actually, whenever you want to find out these things, if you want to make use of the table, you have to express in terms of 0 to z. So that's what I am trying to do. So entire area is 0.5, and I am going to subtract this area from that, 0 to 1.2. Okay. So this area I have to subtract. So this is equal to 0.5 minus, for 1.2 what is the value? For 1.20, that is 0.3849. 0.3849. 0.5 minus 0.3849. That is 0.1151. Okay. So this is the required probability, but I want number of students whose weight is more than 152. That is 0.1151. That is approximately 92. Okay. And because it is number of students, we have to round it off, right? And one more part, third is less than 138. P of x less than 138. So when x is equal to 138, z becomes minus 0.2. Minus means you have to plot it in the left hand side, therefore it is minus. Less than means it is in the left hand side. But because it is symmetric about the line z is equal to 0, I can write it in the right hand side. Again, as we have done in the previous problem, it should be 0.5 minus of, we have to subtract this area. Okay. So this is 0.5 minus 0.2. For 0.2 it is 0.0793. 0.20. 0.0793. 0793. You can use your calculator as well. So 0.4207. This is the probability, but we want number of students whose weights are less than 138 is 336.56, therefore approximately 337. Okay. Next, fifth one, the following are the values of skills of two samples in which with individuals 5 and 6. So n1 is equal to 5, n2 is equal to 6. Because it is small samples and 2 means, therefore small t test you are going to use. And what is the h0? It is always a statement of no difference. So mu1 is equal to mu2, no difference between the means. Okay. And h1 is equal to mu1, not equal to mu2. Therefore, there is no other clue for less than or greater than. Therefore, it is two-tailed. And the level of significance is not given. You can take either 5% or 1%. I am considering 5%. So these are the values xi minus x bar. X bar is the total 1041 divided by 5. Okay, it is 208.2. And here y bar you have to find out. And these values are xi minus x bar the whole squared, and here yi minus y bar the whole squared. Okay, these are the values given. And capital S squared is sigma xi minus x bar the whole squared plus yi minus y bar the whole squared divided by n1 plus n2 minus 2. This is the formula for capital S squared. And when you take the root of S squared, you will be getting 321.685. Just substitute in t-test. T-test, this is the test statistic. T is equal to modulus of x bar minus y bar divided by S into. Just substitute the values, you will be getting calculated T as 0.6916. And the table value of T, and I have taught you how to find out that from the table also. Because it is two-tailed, you have to see 0.25, okay, 0.25. So level of significance is 5% with degrees of freedom. Degrees of freedom, here it is n1 plus n2 minus 1, because two samples are there, it is 10. So T value for table, from the table it is 2.228. So calculated value is less than the table value of T. Therefore accept H0. That means no significant difference between the means. Okay. And a pair of dice are thrown 360 times. Next question. 360 times, and the frequency of each sum is indicated below. What do you mean by this? Two dice are thrown, and these are the sums of the dice. Okay. Numbers are shown on the dice. Out of 360 times, 8 times we got sum 2. And 24 times we got sum 3. For 35 times we got sum 4. This is the meaning. Okay. This is, and you are asked to test the chi-squared level. Here it is again printed as lambda squared. Actually it is chi-squared. Okay. And don't expect full mark just for numbering, putting the number in the paper. Okay. So they will not give unless otherwise you write the formulas at least. Right. So null hypothesis H0, the dice are fair. Here you are asked to find out the dice are fair or not. Alternative hypothesis is dice are not fair. Okay, let the level of significance be 0.05 level because it is given, right? And we know this, this is the probability, right? Probability of getting the sum. These are the probabilities. Already we have done one problem like this. The probabilities of getting sum 2, 3, 4, etc. up to 12. Okay, what are the probabilities? 1 by 36, 2 by 36, etc. In the previous paper also I have explained the similar question. Okay, so you can go through that if you want. So these are the probabilities, and the calculation of chi-squared is y minus, that is observed frequency. These are the given frequencies. You are supposed to get the expected frequency. Expected frequency, expected value means what? Sigma xi pi, right? So sigma xi is 360 and 360 into probability. So 10, 20, etc. These are the values. And y minus ei the whole square, that is observed frequency minus expected frequency the whole square, and each one should be divided by ei. If you make the summation, this is the sigma of this. Okay. So chi-squared formula is sigma y minus ei the whole square divided by ei. This is the value 7.445. and degrees of freedom is here n minus 1. N is what? How many values are given? 11. So 11 minus 1, 10. So this is the table value 18.307. So calculated chi-squared is less than table value of chi-squared. Therefore accept H naught. That is, the dice are fair. Okay. And seventh question, in a recently conducted poll, out of 54 out of 200. So N1 is equal to 200. N2 is equal to 150. These are the values given. Therefore, it shows that it is a large sample, right? And from the large sample, what is mean or proportion? How will you find out? 54 out of 200. This from this out of means what? Proportion. So 2 samples, proportion. So 2 proportion is the formula you have to substitute here. Okay. So P1 is 54 by 200, that is 0.27. These are the values. Q1 is always 1 minus P1, that is 0.73. And here the population parameters are not given, only sample values are given. So directly substituting. So P2 is 30 out of 50. That's why 30 by 150, sorry, 30 out of 150. Therefore 30 by 150 is 0.2. Q2 is equal to 0.8. Okay. Just substitute that values in the formula. Before that we have tried null hypothesis H naught is there is no significant difference between the proportions. Alternative hypothesis, yes, there is a they are not equal. That is two-tailed. There is no other clue for less than or greater than. So level of significance is 5%. And what is the table value? It is 1 point. For 5% two-tailed, it is 1.96. I asked you to remember this table also, 1.96. Okay. So Z is equal to P1 minus P2 divided by root of P1 Q1 by N1 plus P2 Q2 by N2. That is 0.27 minus 0.2. Just substitute those values. You will be getting the calculated value of Z as 1.5453 and table value is 1.96. Therefore less than. Therefore accept H naught. There is no difference between the proportions. Okay. Next is gambler's ruin problem. Actually, gambler's ruin problem means what? 2 players will be, they will keep on playing by betting, okay, for betting, and if one player loses the money 0, when the money of one player is 0, then only the game will be stopped, otherwise it will be continued, the plays will be continued, the game will be continued. Okay, so it is essentially a Markov chain. It depends on the previous step only, that is why it is Markov chain, and the sequence of wealth amounts to the gambler and has at any point of time determines the underlying structure. At any point time, at any time n, let us assume that the N has wealth I. Okay, where I also represents the state of the chain at time n. When the gambler reaches 0 or k wealth, the chain has moved into absorbing state. When will it be stopped? Either one of the players has to obtain 0 or k wealth. Okay, in both the cases it is absorbing state and no more games. Absorbing state means what? It cannot come out of the state. Okay, that is it will be stopped, right? And the transition matrix, actually in this case initially first row and last row will be 1 0 0. The transition matrix will be first and initial and end, it will be 1. Okay, and all the other values are, or the how many other states are there? K minus 1 states, that is 1 2 sorry no 1 2 3 etc. Initially 0, so 1 minus k states. The game will be played, the game will not be stopped, and let us assume that the probability will be p. Okay, in that case, suppose if you are there in ith state, then losing, if he loses, he will lose 1 rupee, $1. That means he will go to the previous state, and if he wins, then it will be he will go to the next step. Okay, so initially 1 0 0 0 etc. and end also 0 0 0 1 etc. and the next will be from 1 first step. This is the initial step, and next step will be either loses or 1 0 etc. So 1 minus p 0 p etc. and here the previous state will be, the last one will be p and 1 minus p and so on. Okay, and we can find out the m step probability. This is the transition matrix. The transition matrix is given by this matrix P, and we can also determine the probabilities of states in multiple step, that is m step transition matrix P per m. Okay, as m goes to infinity, m step matrix will be convergent. The m step matrix is convergent or converges. But it may be convergent, but the stationary distributions are not unique. Okay. So the limit of the matrix P per m has zeros. So the limit of the matrix P per m has all zeros except in first and last columns. So A will end up and all the probability, the last column contains all the probabilities AI that gambler A will end up with K dollars, given that the stated he started with I dollars, while the first column contains all respective complements of AI. Okay, since the stationary distributions are not unique, it means that all the probabilities belong to the absorbing states only. So in this limit matrix, so we can find out the probability using this matrix. So Gambler's ruin limit matrix is given by 1 minus A naught 0 etc. A naught and 1 minus AK 0 etc. up to AK. Okay, so these are the solutions. I hope it will be useful for you, and thank you for listening, and all the best for your results.